DevOps is dead. DevOps is dead. Long live platform engineering. Long live platform engineering. Wait, what did we just hear? Is that true? DevOps is dead. Or is it new kind of hype that is being pushed by some organization? Let's burst some of the myths of DevOps, platform engineering. What is the current situation where we are lying and what impact it has on the current DevOps ecosystem? So let's get started. Before that, this video is brought to you by Commodore SysDig Instruct Slim AI, so make sure you check that out. The more you check them out, the more beneficial it's for the channel because they sponsor my time and I can bring you these content for learning. So in this video, we'll answer some of the most important questions and some of the commonly asked hyped up questions that we see these days. Is DevOps dead? What is platform engineering? What is this hype? What does that mean for you, your startup, or your organization? Now, before getting into this, we should definitely try to define what DevOps actually means. So let's try to step back and understand what DevOps or DevOps principles or the DevOps terminology means so that we can understand where platform engineering fits in. So again, very common terminology and very common example or the definition which is given is DevOps is developer and operations working together. Some might say that DevOps is a culture, it's a mindset, it's kind of collaboration that has to be there within the developer and the ops teams. But the main goal is that you need to release the features faster to production. So when you are creating your application, there are certain stages that are there. So if you see a common typical kind of workflow, you will be having is you have a code, you build that code, you push that code, you deploy that, release that, monitor that, and there is some testing involved. Each stage can be done by various people, or each stage the activities can be divided into different pipelines, and there can be different workflows. Then there can be built different set of automations to make this pipeline more seamless. And that is where all the DevOps tooling will come into play. Like for code, you'll be having Git. For build, you'll be having Jenkins, GitHub Actions. That for push, you'll be pushing to various kind of repositories. For deploying, you'll be using Docker, Nomad, Kubernetes, all these things. And then you will be releasing the application via the URL ingress and whatever you want to use. And then you kind of monitor it using Prometheus and some of the other tooling. So what happens is here, the different set of engineers. So if you look on the left hand side, like if you look this side, you have different set of people who are involved in the whole process, like the DevOps engineer, SRE engineer, ops engineer, build engineer, release engineer, and they kind of will be having a similar set of goals which are there. Now, in some organizations, DevOps is only about automating things. So basically, you need to set up the complete CI/CD pipeline for a particular project, and the developer has to write the code, and the testing also has to be embedded in that particular code. And then you have different set of tools with the entire pipeline which is created till the feature is released. So the concept of DevOps have been adopted by various organizations, whether it's a startup, whether it's a medium size, whether it's a large size. It has helped the users, it has helped the organizations in getting those pipelines set up so that the workflow can be streamlined. So again, DevOps all in all can be considered as cultural best practices, a certain set of tools, certain set of expertise coming in all together where the developers and the operation engineers work in a collaborative manner to produce and ship the features faster to production. That's the ideal scenario. But how that works is sometimes it is not as easy. The standardizations are missing. A lot of different pieces are missing over here. There are no standards. There can be multiple teams within an organization. There can be multiple DevOps teams within the organizations. There can be multiple mindsets, multiple favorite tools which are there, and there can be multiple use cases. So that's how the typical layering would look like. First, to deploy obviously any application, you would need infrastructure layer. whether it's your own data center, whether it's cloud, whatever you are managing. So you have the base infrastructure layer that has to be set up. So you need to have the hardware, or you need to have the cloud resources which is being provisioned. Then you need to have environment set up on top of that, like what sort of environment you want your applications to run in. That depends whether you are installing or using Kubernetes, or whether you are using Docker with EC2 instances, or whether you are using any of the tooling out there to set up the environment for your application with all the dependencies and stuff like that. Then you actually deploy your application. So you will be having the deployment of your application. So you obviously need to have build the application, test the application, and then deploy the application. Then after the application is deployed, you obviously need logging and monitoring for your application. You need to see the logs, you need to see what went wrong, if anything went wrong, and then how to monitor your application to see whether the application is up and running all the times, and if you need other statistics from your application. Then comes your security layer. So you need to have that sort of security layer. They are not in the order, like security doesn't have to come in the infrastructure environment layer. So it's basically security has to be at all layers which are there. So you need to have that. Then doing it all in an automated way. So it's as a CI/CD pipeline, how to do it as a CI/CD pipeline, and then how to automate more and more and more stuff and implement more tools. So when we talk about different set of toolings, each team has a project, and each project can be unorganized because there can be different stacks depending on the expertise level, or the favorite level that can be there. Like someone can like Jenkins, another person can like GitHub Actions. So there can be different taste and flavors of what you want to use depending on the use cases. So this kind of process lacks standardization, and it includes the replication. Like you have to build same stuff again and again. You have to build those pipeline again and again. You have to build those certain cultures again and again, because different teams having different set of DevOps pipelines, different set of DevOps practices is not a standard organized way of doing things. Like you will be wasting a lot of resources and time in doing things, repeating again and again with less of the standards. And also, if you see the CNCF landscape, you can see it's massive, right? Because for each particular problem, the number of tooling is massive. Like there are so many tools that can solve the same problem. So you have to carefully analyze the landscape, your problem, and then see which tooling will fit you. So this was what DevOps is, and some of the challenges that DevOps brings in, and that is still being practiced across, and people still practice the same practices. But now we are seeing a new trend which is coming up. Which is coming up really, really hard on different social platforms, and it is being pushed by some of the organizations as DevOps is dead and platform engineering is replacing that. Now, again, we'll come to that question later in whether is DevOps actually dead, and is platform engineering everything, and what happens to those DevOps engineers. So let's first understand what platform engineering is. So platform engineering is basically the internal developer platform. What does that actually mean? Let's take two kind of scenarios. Let's say I buy a particular laptop, and the laptop has standard set of tools which are there that makes my life easier. I don't have to build my own tooling. I don't have to use different set of tooling. So each organization can have standard set of security tooling and all these tooling pre-installed onto that, and I can start using my laptop as it is. So it increases my productivity. It has standard tooling across the organization, and I do not have to worry about creating my own tooling because I will be able to use that. Same for the phone. Let's say I buy a phone. There are different default apps which are there. I don't create a separate app for sending, XYZ messaging. I'll be using the standard apps which are there by default. It makes my life easy. So there are standard set of defaults, and that defaults make your life easy, and it becomes a standard. So similar to that, you have internal developer platform that tries to standardize different practices across the teams. So I told you before that DevOps is every team is doing it differently within one same organization, which is not the right practice. The right practice is everyone following certain set of standards, and that certain set of standards can be provided by platforms, the internal developer platforms. So internal developer platforms, or IDP, can be the set of abstractions for the developers or the application engineers to just request what they need and they get it from the platform. So let's try to simplify internal developer platforms a bit more. So let's say you have 4 teams. You have Team A, Team B, Team C, Team B. Now, Team A also wants a Kubernetes cluster. Team B also wants a Kubernetes cluster. Team C also wants a Kubernetes cluster. Team D also wants a Kubernetes cluster. And they have their own, like they will be creating the Kubernetes cluster, but with slightly different configurations because according to their own taste. But in the end, they just want a Kubernetes cluster. So an internal developer platform can be a set of API where Team A can request from the IDP that I need a Kubernetes cluster, and they get a Kubernetes cluster. Team B can request that and they get it. Team C can also do that and they get it. Team D can also do that and they get it. So IDP creates a standard. So all 4 are having the same kind of configuration, same kind of clusters that they are getting. And then similarly, if they need a database, they do it in a similar way. Similarly, if they need a build tool or a pipeline workflow, so there can be a set of API that will give them the standard default workflow which is there and that they can readily use. So they can request a particular project in the internal developer platform. That's a hypothetical example. They can request a particular project in that internal developer platform. That project will be assigned to Team A. That Team A will be given a certain set of resources. It will be given a cluster, whatever they ask for, with the set of APIs that are there. And then they will be able to use those. Now, Team A, B, C, D, all teams do not have to do any research. So basically, the developers, they just want their application to be deployed, and they want their application to be deployed in an automated way because they want to ship the features faster. Now, in that particular process and in the automated way, they all don't need to research the tooling. They all don't need to build any standards. They can just go to the internal developer platform team and say that I need these set of things. And then the IDP will come back and say that we already have these many standard set of tools that you can choose from. So you have that particular standardization which is built in from the internal developer platform. So the pain points of repeating the code identification is removed. It reduces the research efforts, improves productivity, improves standardization across the teams within the organization. So that's where the internal developer platform helps. Now, who actually builds these internal developer platforms? Again, it is built by the same people. So internal developer platform also needs to be built. It has to be built in a way that it actually solves the purpose of productivity and reduces the repetitive efforts that each team is making. So you can also consider it as an internal cloud platform that you build for your organization, and it is built by the same people of developers, ops teams, SRE, different titles which are there doing the same kind of work. So classic example can be Backstage. It's basically an open platform for building developer portals, which is the developer platforms which are there. The various building blocks that you can connect together to build a complete portal, and developers can use that. It can become a standard. It has a whole catalog which is there, and you can view that. You can have your own software templates. You can have all these things with the plugins which are available. Spotify built it for their own company, and they saw the productivity increase, the reduction of the repetitive efforts which have been there by a huge extent, and that is where they contributed Backstage to the community so that other people can also use that for their internal developer platform. Now, there can be various features that you can put in the internal developer platform, but that depends on the most common features that is being used by the team. Then only it makes sense to include those in the internal developer platform. So, for example, like the build tooling, I said, the deploy tooling that can be built. But if there are something very custom to a particular team, that can be built by the team itself and not in the internal developer platform, because that is something you have to realize and talk to the teams if this particular feature will be used by other teams as well. So that can be incorporated as an API or a plugin with the IDP. So I think the hype is there. Obviously, we have seen like the DevOps, like I was holding that DevOps is that long-lived platform engineering. DevOps is dead in a way that people are pushing it, which is fine. I don't really care. And it should not be that much of an impact to the existing DevOps engineer, SREs, and all the titles which are there, because in the end, they will be doing the same set of work for creating those internal developer platforms. Whether you have your, Argo workflow set up for your complete project, and anything that you commit, the internal developers, everything goes and it gets deployed as a particular piece of the puzzle. So you will be doing those set of scenarios instead of building multiple pipelines and doing it with the different teams. Your title can change. That should not be a problem. You can, instead of a DevOps engineer, you will be called a platform engineer, but you will be doing kind of the same work because you will be developing those. You will be having the the API programmers to build those APIs. Then you will be having the infrastructure engineers to build those infrastructure, and then abstracting them from the developers from the consumers who are your teams in this particular case. Now, let me give you another example, which is similar to cross-plane composition. If you don't know, then you can check out the cross-plane composition deep dive video. But the concept basically is that in the internal developer platform, the abstraction that the platform engineers will be creating is that they will be having multiple clouds as per their company standards, and they will be creating an abstraction of getting the Kubernetes cluster. Now, as an end user, the end user will just say, I need a Kubernetes cluster with 3 nodes. I don't care which cloud provider, whether it's bare metal or whether it's Civo, whether it's AWS, whatever the stuff is. I don't care about that. That depends on the internal developer platform team, the abstraction that they have created. So the team A will just request for a Kubernetes cluster, and based on their requirements, they will be getting the Kubernetes cluster with the pool that is created behind the scenes. Similar to that, there will be other set of abstraction for all the other sets. Like for the databases, they don't care which database. They just say, I need a MySQL database with this many size. They don't care where it is running it. So that depends on the platform team. So that's how the standardization is being created. The productivity is increased because the teams don't have to focus on what they have to create and where they have to create. The team just need to focus. They need this to do their work. And then the platform has to be focused on giving those abstraction layers which are there. So that is how I think the platform engineering thing is. DevOps is dead, but the practices will still remain as part of the platform engineering. We are moving towards an era or the next set, basically the next advancement, you can say, in the DevOps ecosystem, where you are now moving towards a standardization across your organization. So you are moving towards less repetition across your organization, standardize across your organization, simple CI/CD pipelines, simple developer portals, internal developer portals that will be used by your teams. So that is what internal developer platform is. So I hope you got the gist of what DevOps was, how we are moving towards IDP, and who are the engineers or the people who are building it. So your jobs are not at risk. So people who are thinking, if DevOps is dead, then who will be doing that work? It's you people who will be doing that work. So it should be fine from the jobs perspective, in my opinion, because in the end, you will be building those infrastructure layers and then providing these abstractions. So you will be needing those SREs, you will be needing those infra people, you will be needing the ops people, you will be needing the API engineers to build those APIs and abstract them from the teams. I think nothing is at risk, to be honest. There are some organizations who are pushing it really, really hard that we only need platform engineers. But if you see the job description of the platform engineers, they are just the same. You need to know the cloud, you need to know these many tools, you need to know that. So it's actually very, very, very similar job description to a DevOps engineer. So DevOps may be dead, platform engineering may be the next new thing, but in my opinion, it's just the next set or the next iteration, or just the way we are improving DevOps ecosystem, and we are calling it as platform engineering because we want to build the internal developer platforms to standardize stuff across the organization. So I hope you got gist of what DevOps is, internal developer platforms, how they correlate with each other, and who built them, and there's no one who is at risk. Thank you so much for watching this video. Again, a big shout out to all the members. Commodore Sysdig, Instruct, Slim AI. Links are in the description. Make sure to check them out, because the more you check them out, the more benefit it is for the channel. And make sure you like the video, share it with your friends, and subscribe to the YouTube channel so that I can bring you, this content which is there. Do the standard stuff, okay? And share your thoughts on DevOps versus internal developer platform, what you think are IDPs and platform engineering is, and if you think DevOps is dead. So thank you so much for watching this video.